we can find all 10 angles. Okay, what I've done is I've gone ahead and printed up this, and I've gone ahead and labeled the given information, but let's review it real quickly. We've got BE is a diameter, so we have a diameter right here, so we know we've got 180 on each side. Okay, we also know that AT is a tangent, so that means point A is a point of tangency, and we can assume that that's a tangent line. AB, the arc from A to B is 80 degrees, and the arc from B to C is 20 degrees. Notice those actually look almost the same size. So this is not drawn to scale, so don't be surprised if we get some odd angles here. And then DE, which is this smaller arc up here, is 50. So I've labeled those 3 angles already. Now we're trying to find all 10 angles at the bottom of the page, but rather than being focused on just like finding angle 1, finding angle 2, we're just going to work on the diagram and then go back and fill in our answers. Okay, so let's go through and see what we can figure out. Well, immediately I know that if this arc is 20, my central angle right here must be 20. Okay, and if I know this is 20, then this side is its linear pair. So this side must be 160. Okay, so I can immediately start doing those. Now, let's go to this 80-degree angle, or arc. This 80-degree angle arc is part of the bow tie. Do you see the bow tie? Angle 3 we can get from averaging, using the bow tie rule, these 2 arcs, the 50 and the 80. So the average of 50 plus 80, let's just 50 plus 80 is 130 divided by 2 is 65. So that means this is a 65-degree angle. So we actually have angle 3. We have an angle 8 so far. Okay, so now let's see what else we can get. Angle 1 up here, what type of angle is it? It's an inscribed angle. So we need to look at the intercepted arc. Let's extend the sides. So we're going from, oh, it's arc AB, isn't it? Because if we extend the sides of angle 1, we get from A to B. So if this is 80, angle 1 is 40. Okay, so let's see. Angle 2, let's see what arc it intercepts. It is also, the vertex is on the circle. So if we extend both sides, we're going from A to C. So what is the arc measure from A to C? Well, it's 80 plus 20. So it's 100 degrees in its intercepted arc. So since we're going backwards to the angle, we're going to take half of the sum, so that's 100, so this one's going to be 50. Okay, so we now have angles 1, 2, and 3. Okay, let's look for another angle. How about angle 4? That's one of those outside angles. And if you remember, we have 2 intercepted arcs, the larger one and the smaller one. So what is this formula for an exterior or an outside angle? Big minus small divided by 2. So the big arc is from A to C. See how that extends? So from A to C is 100. So we'll take 100 minus 50 all divided by 2. So 100 minus 50 is 50 divided by 2 is 25. So that means angle 4 is 25 degrees. Okay? Now let's see what else we can see. Let's go on to angle 5. Angle 5 is a tricky angle. It's this angle right here. So look at it carefully. What type of angle is angle 5? Well, angle 5's vertex is A, and we know A is a point of tangency. So it's on the circle, and when a vertex is on the circle, it means it's inscribed. Even though we're dealing with a tangent, you always look at where the vertex is. It's on the circle, so it's half of the arc. Well, what arc does it intercept? Well, it's going from A to B, isn't it? So this arc is 80, so we know that we're going back to the angle, which makes it smaller. So this is 40 degrees. Okay? Angle 6 right here is also an inscribed angle, and it also has A as the vertex. But let's extend the sides to see what we have here. We have one side of it is from E to E, and the other side of it is to B. What do we know the arc from E to B measures? Well, they told us that EB was a diameter. And if EB is a diameter, that means that's not 180 degrees. And when we have a triangle inscribed with the diameter as the hypotenuse, we know it's half of that arc, right? So if this is 180, angle 6 is 90 degrees. So that's a right triangle right here. ABE is a right triangle. Okay, let's see which other ones are we missing. We've got 8 already. Here's 7. Okay, look where 7 is. Its vertex is on the circle. It is also an inscribed angle. Extend the sides. So we're going from A over to E, A to E. Okay, we need to know that arc. We don't have that yet. But we know BE is a diameter. We know this part is 80. We know this part is the other half of the circle. So let's see, 80 plus 100 would make 180 for the diameter. So this arc has to measure 100. That means if we work back to the angle, that's got to be 50. Okay, so angle 7 is 50. We have angle 8. We're up to angle 9. Okay, here's angle 9. Notice 9 has a vertex at A. What are the sides? Let's see. From A it goes to D. From A it goes to E. So we need to know this arc. Well, they gave us that one. That's 50. So that's inscribed. It's half. So angle 9 is 25. Okay, looking at angle 10. We're down to our last angle here. Let's see. Angle 10, the sides are A to E and A to T. Okay, again, angle 10 is like angle 5. It's tricky, but notice the vertex is on the circle. That's how you decide what type of angle it is. So this one's inscribed. So from E over to A, what's the arc? The arc is 100. Therefore, the angle that's inscribed has to be 50. And there you go. That's how you would figure those angles and arcs out. So anyway, those are the 10 angles, and you can fill in at the bottom if you need to.